All right, welcome to 2024. This is our first video of 2024. Today is January 8th. Oh, yeah. Oh, my God, are we in 2025? That makes me really old since I was born in 72. Wow. Okay. Question 3 says, give two examples of a polynomial that satisfies all statements. So it has to be two different polynomials. So a polynomial is more than one term. A monomial is one term. So has to have two terms, which means we're going to make binomials. Okay, I can visualize that. Has to contain two different variables. Actually, it doesn't say it can't be the same variable, does it? So it can both be the same variable, or it can be different variables. The polynomial has to have a degree of 2, which we studied yesterday, which is a little confusing, but it's okay. But one of the terms has to have a degree of 1 and the coefficient of 1. Okay, so here we go. The polynomial, it's a binomial, has to have two variables. The binomial has to have a degree of 2. And of those two terms, one of them has to have both a degree of 1 and one of them has to have a coefficient of 1. Okay, I got the answer. So I'm going to make the standard binomial, x squared plus x. I'm just going to use that. Or if you took this part here as variables, meaning have to be different, instead of having an x, I technically could have a different variable. I'll use y, just to keep it kind of copacetic. If I look at the degree of each term, this term has a degree of 2. This term has a degree of 1 because the degree of a term is determined by the exponents on the variables. The degree of the binomial is not determined by the sum of all of the terms' exponents. It is looking at both terms, which one has the highest degree, the first term. The entire binomial, therefore, has a degree not of 3, but of 2. So this whole polynomial, would have a degree of 2. Weird, I know. Why? I don't. The second thing is, what's the coefficient here? There's none written, but what is it? 1. So does one term have a degree of 1? Or sorry, a coefficient of 1? Yes, it does. Does one of the terms have a degree of 1? Yes, it does. Which one? The y does. It has a degree of 1. So therefore, the polynomial has a degree of 2. Yeah. One term is a degree of 1. Yeah. One term is a coefficient of 1. Yep. There's two variables. Yep. And it has two terms. Yep. X squared plus y is my choice. Another one you could use would be degree of, oh, let's go with this. Is that a monomial? Yes. Does it have a degree of, what's the degree of xy? Carter, what's the degree of xy? No. What's the degree of xy? Y. Because the coefficient, the exponents on the x and the y, although not written, are both 1, correct? And since the degree of a term is based on the sum, adding together, of the exponents on the variables in a term, this would have a degree of 2. This would have, that's a z, by the way. xy plus z, binomial. Good. Done. One term, two terms. Perfect. Does it contain two variables? Well, it actually contains three variables. Is that going against the rules? Maybe, but that's okay. But it does have two variables. Didn't say you can't have 3. 1, 2, 3 variables. Good. Check. What's the degree of the first term? 2. What's the degree of the second term? 1. Good. So one term does have a degree of 1. What's the coefficient of xy? How many xy's do we have? Just 1. It's not written, but it is a coefficient of 1. And the z would have an imaginary or a unwritten coefficient of 1. That's my second one. And you can have other ones as well. But that's the gist of what you'd have to have. That was a long 4 minutes for one question. Question 4 says, when is it acceptable not to write a 1 in an algebraic expression? Well, we just talked about it. You don't have to write 1s when it's your exponent. It does not have to be written of 1. And when it's a coefficient. So when do you not write 1s, or it's okay not to write 1s? When it's an exponent or when it's a coefficient? when must you write the 1? Second question. You must write the 1 if it is your constant, right? The only time you definitely have to write a 1 is if it's your constant. And I'll write that down here. So constant, your plus minus value. So when the term is just a constant, you have to write the 1, or a minus 1, it doesn't matter. Question 5, for each expression, identify the number of terms, first thing, and whether the expression is either a monomial, binomial, trinomial, or more than 3 terms, a polynomial. So, question A, 1, 2, 3, trinomial. 3 terms, trinomial. Question B, 1 term. How do we know it's 1 term? Well, remember, a term by definition is the product of numbers and or variables. Since negative 11a is really the product of negative 11 multiplied by the variable a, it's just multiplication, and therefore is just 1 term. Negative 11a is 1 term, or a monomial. C times C plus C times F plus D times F minus F times F. 1 term, 2 terms, 3 terms, 4 terms. Therefore, it's a polynomial. 4-term polynomial. And the last one is just 1 term. It's just a constant, and it's a monomial. It's just a constant, and it's a monomial. What's the degree of D? What's the degree of 8? 0, because there's no variable. What's the degree, even though it's not asked, what's the degree of the polynomial C? 2, because degree of 2, degree of 2, degree of 2, degree of 2. Of all 4 terms, which one's the highest degree? Well, they're all 2. So the degree of that entire 4-term polynomial is just 2, not counterintuitively 8 like you might suspect. The degree of B would be what? 1, and the degree of A would be 2. Are we okay with that? All right. Question 7, refer to the polynomials to answer the question. Which ones are monomials? I'll put M's. Monomial, it is the product of 6 and x. Monomial, it is just a constant. Those are your only monomials. Trinomials, 3 terms. 1, 2, 3, linked together, and we talked about it by addition or multiplication or subtraction. This is a trinomial. That's it. And which ones have 2 terms? This one has 2 terms, making it a binomial, and this one has 2 terms, also making it a binomial. The last one is just a polynomial, 4 terms. No problem. Yep. That's not a terrible question. I'll give you that. Question 8. For each polynomial, what is the degree and number of terms? Okay. A, how many terms? 2. Bryn, what is the degree of 4 minus b? 1, because the exponent on the variable of the only term is a 1 that we don't have to write because we already said we don't need to write exponents of 1. Done. Question B. Mike, how many terms? 2. Degree of the entire binomial is not 1. Shirzad, what do you think? Why? Correct. The f is a variable. So really, if I said it's f times g, that's what fg is, right? F times g plus 2 times g. There's our things. Exponent on the f is 1. Exponent on the g is 1. So therefore, fg has a degree. I know Mike knew this. Degree of 2. The second term has a degree of 1. The entire binomial, therefore, has a degree of 2 based on only its highest degreed term. And finally, Mike, redeem yourself, sir. C, how many terms? Degree of the entire trinomial is? 2 is correct. Degree of 2, degree of 2, degree of 2, degree of 2. Okay. Question 10, refer to the polynomials below to answer the question. Which ones are binomials? Okay. Now we skipped ahead to this one here. Binomials. Binomial. Binomial. If I ask you on a test, why is this one a binomial? You will say it is the product of 2 and x minus y times y. Term 1, multiplication of either numbers or variables, a term. Term number 2, the product of just y and y, or a negative y and y. Which ones have a degree of 2? I'll use a red marker. This one has a degree of 2 because the variable in that term is b. The exponent is 2, therefore its degree is 2. This one has a degree of 2. It's 3 terms. This s has a 1, this t has a 1, the degree of 2, degree of 1, degree of 0. The entire trinomial has a degree of 2. And finally, this one also has a degree of 2 because it's a binomial. Both terms have degrees of 2, and therefore the entire thing is a degree of 2. Finally, what is the variable in the monomial? Well, since there's only one monomial, the variable is b. And finally, which polynomials have a constant term? Okay, let me erase this because it's a little crowded right now. How many of those 4 answers have constants? Carter, how many of those 4 polynomials have constants? Incorrect. 2. Can you tell me which ones they are? Say it again. Does this one have a constant? Nope. Mike, redeem him. Okay, which one's the constant? Because it's a term with no what? No variable. A constant, Carter, just so you won't forget, is a term in a polynomial that does not have a variable. And the only other one that has it is this one here. And if I asked you what is the constant in that trinomial, don't say 1. Say negative 1. Okay? So in that trinomial, if I said, what is the constant, you would say it's negative 1. Okay? Question 11, we're really good at these because we just did a whole bunch of them. What expression is represented by the set of algebra tiles? This is x and x, therefore it would be 2x. This is negative 1, and negative 1, which would make it negative 3. So that picture represents the binomial 2x minus 3. This tile is an x squared. This is a negative x. This is a negative x. This is a plus 1. So we'd have a 1x squared, no coefficient needed. A negative 2x's, which is what these will become when put together properly. And then a plus 1 is a, Carter, what do you call that plus 1 again? Good stuff. Trinomial, the constant term is plus 1. And your last one, since it's not shaded in, it's an opposite of x squared or a negative x squared. And if you really, really insisted, you could say negative 1x squared, but that's poor form. Plus 3x and minus 2, a trinomial. Constant term being minus 2. And we have just enough time to do 13, and then I'll let you guys finish the rest of the questions on your own. Model each polynomial. X squared, first term, big square, shaded in, x squared. Second term, plus x, a rectangle, shaded in. Because it's positive, we will shade it in. And the last term, your constant of minus 1, is going to be a small little square or an algebra or an integer chip, not shaded in because it's negative. X squared plus x minus 1. Binomial, 3 x's will be an x, and an x. That is positive 3 x's because they're shaded in. And a positive 2 will be a small and a small 3x plus 2. And your last term is just a monomial of negative 2x. Remember, it's the product of negative 2 and x. What does that look like as a algebra tile? That's a negative x. That's a negative 2x. And that's your answer. Okay, that's up to 13.